side BC, okay, which is right here, that's this whole side here, is congruent to what side on the other triangle?
DC.
Okay, to DC right here. Now, how do you know that those two are congruent to each other?
Because they both have three. They both have three lines.
They both have 2 lines.
Okay, because of these 2 lines right here on this side. See, the side from here to here has 2 lines. The side from here to here has 2 lines. Now you're talking about these angles, and that can kind of get you to the right place in the first place. But you can see BC has 2 marks, and DC has 2 marks. Okay. Now the other thing here is angle B. So angle B is congruent to what angle on the other one?
D.
Angle D. How do you know those 2 are congruent?
Because of the angles.
Okay, because those do have the 3 marks on there.
Good job, I said.
There's 1, 2, 3. 1, 2, 3.
Nice shirt, too.
Okay. Number 6. Angle S is congruent to what angle?
T.
T. N. Angle N.
Oh, wait.
Angle in.
N.
It's on the other triangle.
Angle N.
Is angle N. Okay. Angle S has 1 mark.
Told you,
Angle
man.
N has 1 mark.
Good job, I said.
Okay. Angle R is congruent to what angle?
M.
To angle M. How do you know R and M are congruent?
Because they both have the three.
They both have the 3 marks on them. Okay. All right. On number 7, angle F is congruent to what angle?
7.
Number 7, angle F is congruent to angle P. Angle E is congruent to what?
R.
To angle R. Okay, guys, need you to pay attention, please. All right, VU is congruent to what?
XW.
Okay, good, to XW. Because this has V has 2 and XW has 2, and it goes from 1 to 3. So from 1 to 3 would be XW. All right, and then angle U is congruent to what?
Angle W.
To angle W.
They just double it.
Okay, now on the back of your warm-up, I want you to look at these triangles back here. Okay, these 2 triangles right here. Are these 2 triangles congruent to each other?
No.
Yes.
Okay.
No.
So let's cut them out and see if they're congruent or not. Oh, what's going on? Okay. Okay. So are these 2 triangles congruent to each other?
Yes. No, wait, no.
Are these 2 triangles congruent?
Yes.
No.
Okay, if you cut them out, lay them on top of each other,
No.
are they congruent?
Almost.
No.
Okay. So the answer is no. You can see there's a little bit where the other one's a little bit bigger.
I was right.
So that means they're not congruent. To be congruent, they have to be exactly the same shape and size. They're the same shape, pretty much they're similar to each other, but they're not the same size. Okay? So these 2 triangles right here are not congruent to each other. Okay, these 2 are these 2 congruent to each other?
Are we supposed to go those out?
No, I'm getting to it in order here. Are these 2 congruent to each other?
No.
Okay, let's cut them out and see.
Oh.
Cut both of these out and let's see. Okay, are those 2 triangles congruent?
No.
Yes.
So actually, if you cut them out,
Yes.
all right, stack them on top of each other, you see, actually, yes, they are congruent to each other. Those two actually are congruent to each other, okay? Now, these two triangles right here, the last two, are those two congruent to each other?
Obviously not.
No, there's no way these two are congruent to each other, okay? There's no reason to even cut these out. So here's the thing. Sometimes, like on these, they look like they're congruent, but they're not. And then sometimes like this, I intentionally did this, like rotated it to where I made it look like they're not congruent. It's just an optical illusion. These look like they're not congruent, but once you cut them out and stack them on top of each other, you see that they are congruent. Okay? So some are obviously not congruent. Some look like they are, but they're not. Some are, but they look like they're not. Okay? So that's what we're going to do today is we're going to talk about how can I tell if two triangles are congruent without having to cut them out like this. Okay? And there's several different methods, but we're going to talk about two of those today. Alrighty. Let's go ahead and look over here. So these are our two methods we're going to use. So we're going to have SSS and SAS today. So the SSS, side congruence. If the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. Okay? If all three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. So this is where you wouldn't have to cut these two out. Okay? So the abbreviation for side obviously is SSS. So here's what I want to do. Okay, so side AB. Side AB on this triangle. Okay? That is congruent to which side on the other triangle? To ZX. How do you know those two are congruent?
Because of the single line.
Because of the single line. So AB is congruent to ZX. Okay, next let's talk about these two sides. So side BC is congruent to what?
YX.
To XY, yep. Yeah, remember the order does matter there, so it's BC to XY. And then AC is congruent to what? To ZY. Okay? So here's what I want you to see. When I say that AB is congruent to ZX, I'm saying that that is one set of sides that are congruent, okay? So that is one set of sides that's congruent to each other. Then when I say BC is congruent to XY, I'm saying that's another set of sides that's congruent between those two triangles. And then finally, when I say AC is congruent to ZY, I'm saying, okay, so then the third set of sides, those are congruent also. So this is SSS, okay? Sides. These two sides are congruent, that's one of the S's. These two sides are congruent, that's another S. And then these two sides are congruent, that's the third S for this one. All right. So that's that in a nutshell. We'll get more into that in a second. The other type we're going to look at is side angle side. So this is if two sides and the included angle, okay, and this included angle is definitely important for side angle side, and we'll define what an included angle is in just a second. But if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Okay, we will come back to this part of it in just a second, but let's drop down here and let's talk about what included angle means real quick. Okay, so included angle is the angle formed by two sides. Okay? Included angle is the angle formed by two sides. The angle formed by two sides. So, like on this triangle right here, I have AB and BC. So I want to know, what is the included angle of AB and BC? So here's AB and here's BC. So what angle do those two sides that I just shaded in purple there make?
AC.
No, what angle?
90.
Okay, yeah, it looks like a 90-degree angle, but what's the name of that angle?
Right angle.
Nope, that's the type. What's the name of the angle? I mean, it's so easy you're overlooking it.
Quadrilateral.
Okay, good. Angle B. Exactly. See how those two sides right there make this one angle? So the included angle for side AB and BC is angle B because those two sides make this angle. Okay? Next one is DE and FE. So here's DE and FE. So what angle do those two sides make?
D.
Is angle E. So the included angle of DE and FE is angle E. Okay, next one is QR and RS. Here's QR, here's RS. Okay? So yeah, they make angle R. So the included angle of those two is angle R. And then the last one here is MN and MP. So we have MN, MP. What angle do those two sides make? Angle M. So angle M is the included angle of those two sides. Okay? So that's all an included angle is. Very easy. It's just the angle that the two sides make. Now let's go back up here to our side angle side. Okay, so obviously the abbreviation for side angle side is SAS. Now what I want you to notice here, let's start off with this. So this side AB. Okay? So side AB is congruent to what? Good, to side FD. And again, how do you know AB and FD are congruent? Yep, there's one little mark there, there's one little mark there, one little line. Okay? So AB is congruent to FD. Now the next thing I want you to notice is this little mark right here. So what did that little mark mean?
Angle.
Yeah, that means that that angle is congruent to that angle. So what's the name of this angle?
B.
B is congruent to angle
D.
D. Okay? So we have angle B is congruent to angle D. And then the other piece of information, what's the other piece of information that's marked up here?
The other angle.
Okay, so I know that this side is congruent to this side. I know this angle is congruent to this angle. So what's the other thing that they have marked on this picture for me?
The side.
A side is what? BC congruent to... So BC is congruent to side what? DE. Now, we'll get to more of that in just a second, but I want you to look at this. With the way I marked it, this side's congruent to this angle to this angle, and this side to this side. Is this angle right here the included angle of these two sides?
Yes.
Yes, because the included angle just means the angle that those two sides make. So that's good, okay? This is the included angle. All right? So back over here, I want you to notice this. When we say AB is congruent to FD, we're saying that is a set of sides that are congruent to each other. When we said angle B is congruent to angle D, we were saying that was the included set of angles that were congruent. Angles. And then when we say BC is congruent to DE, we're saying that these two sides are congruent. Okay? So that's one set of sides that's congruent, the included angle that's congruent, and then the other side, that's SAS. So that's that in a nutshell. So down at the bottom of the paper here, I've got these 6 pair of triangles here. And I want to go through and decide, is each one of those an example of SAS or SSS? Okay? So like on this first one, these two triangles are congruent. And are they congruent by SSS or SAS? Is this an example of SSS or SAS? Okay, good. So if you'll notice that this side is congruent to this side, right? So that's one set of S's that's congruent. What does this little mark mean?
Angle.
Angle. So that's saying that this angle is congruent to this angle. So there's a set of angles that are congruent. And then what do these little marks mean right here? Side, that this side is congruent to this side. So this side is congruent to this side, so that's another set of S's. So these two triangles are congruent by SAS. The side, the included angle, and the other side. Okay, on this one, what do you think this is an example of?
Side, side, side.
Yeah, this is good, right? This side is congruent to this side is congruent to this side, and this side is congruent to this side. This is S, S, S. And SSS usually is one of the easiest ones to recognize, especially when we get into all the other methods, but that's pretty easy to see most of the time. Okay, on this one, what do you think this one is an example of?
Side, angle, side.
Good. This side's congruent to this side, this angle is congruent to this angle, and this side is congruent to this side. So we have side, angle, side. Okay, what is this one an example of?
Side, angle, side.
Okay, this side is congruent to this side. This angle is congruent to this angle.
But that means that the other side has to be equal to the other side.
But it doesn't tell us that.
But you should conclude it because we're not doing side, angle, angle.
We can't assume that here. So this is kind of a trick question. I just wanted you to see this. Okay? So this one, you don't know anything else. It's not giving you anything else. So what we're going to do, and this is what you'll do on your assignment with problems like this, you're going to put NEI here, which stands for not enough info. Not enough info. Because here all we have is one set of sides and one set of angles. So this is basically just SA, and SA is not enough information to prove congruence. We won't see that method in anything that we do over the next few days. So if that's all you have, that's NEI, not enough info. Okay, what about this one?
Side, angle, side.
Side, angle, side. Yep. Okay. And then what about this one? Is S, S, S. Okay. So this is side, side, side. Okay. So on the back, at the top here, what we're going to do is we're going to state what it is, what additional information you'll need for the particular method. Okay? So, like on this first one, I would like to use SAS. But there's not enough info up here, just like what we saw just a second ago. I want to use SAS, there's not enough. So what I want to do is say what extra piece of information I would need to be able to use SAS. So let's go through this first. Okay, I see this little mark and this little mark. So what is that telling me about this? Okay, good. That's telling me that this side is congruent to this side. Okay? So that's already one of the S's. So here's what I'm going to do. Let's write that down. So AB is congruent to what? To XY. So that's already one of those S's. Okay, next thing I have this marked. So what is that telling me? That's a pair of angles that are congruent. So let's write that down. So what would I say on that?
Angle B is congruent to angle Y.
Good, angle B is congruent to angle Y. So that's a set of sides that's congruent. That's the angle that's congruent. So what else do I need to be able to use SAS?
An extra side.
I need another pair of sides, right? And this A needs to be the included angle. So it needs to be the angle that's made by these two sides. So what set of sides would I need to know up there?
BC.
Good. I would need to know that this is congruent to this. I would need to know that BC is congruent to what? Yeah, YZ. Okay, so that would make side, angle, side. So this is the extra piece of information that I would need to use side, angle, side. Okay, and the second one, I want to use SSS here. So what do I already know up there? Okay, I already know that M is congruent to QR, so that's one of the S's. What else do I know? NO is congruent to what? To RS. So that's another one of the S's that I have. So what am I missing then? Yeah, the third set of sides. So what would I need to know? Okay, we can do it like that. OM. And since you're naming it like that, we can do that, it's fine. But if I say OM, I have to say SQ. Okay, I have to know that this side is congruent to this side. All right, and then that gives me my third set of sides. So that's good. All right, on this last one, I want to prove those two are congruent by side, angle, side. Okay, so what do I already know up here that's marked? The sides. Okay, so let's talk about it. What are they? AB is congruent to DE. That's one of the S's. What else do I know? Okay, side BC is congruent to side EF. So that's another set of sides. So what am I missing then? The angle, and it's got to be the included angle, so it's got to be the angle between those two sides. Right, so it's this one, and then this one and this one. So what angle do I need? Okay, good, B and E. So I need to know that angle B is congruent to angle E, and that is the angles that I need. Okay, let's look at these real quick. These are simple. So we're going to state whether we could use on these first three, if we could use SSS. So on this one, is there enough info here to use SSS to prove these two triangles are congruent? No. Right? Because that's just two S's on that, right? Okay, on this one, is there enough info to use SSS? Okay, this one is a little bit weird, and the answer is yes on this one. Let's talk about why. So you know that this side is congruent to this side. So that's one set of S's, right? So you know that's congruent to that. You know this side is congruent to this side. So that's already S and S. So the only other thing we need is one other S. So if you just think about this, okay, just common sense. If you were to take these two triangles and split them apart, what would you know about this side on this triangle and then that same side on this triangle? What would be true of those two sides? They would have to be equal to each other just by common sense. Since they got split apart, they would be the same thing. Right? So that actually is a third set of sides right there. So this one actually is, yes, you could use side, side, side on that one. Okay, what about on this one? Okay, on that side, same thing would happen here. Those two sides would be congruent to each other. But do we know anything about this third S over here? Nope, so this one's actually no. Okay, these last three we're going to look at. On these, we're going to say if we can use SAS. Could I use side, angle, side on these two triangles? And the answer is yes, and again for another thing that we've talked about in the past. Oh, yes, very good. What did you say? Vertical angles, exactly. That's perfect. Okay, good. Remember, what do we know about vertical angles? They're always congruent. So this is an example of side, angle, side. So on this one, yes, you would be able to use side, angle, side. On this one, could we use side, angle, side? Those sides would be congruent. Okay, think about it. Is this 70 the included angle for this side and this side? Is the 70 the included angle of this side and this side? No, it's not. The included angle would be this angle, not this angle over here. So on this one, and we'll talk about this, this is actually an example of SSA, which does not work. So this is no. All right, and then last one, could you use side angle side on this one? This one's definitely no. That's angle, 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 which does prove similarity, but not congruence.